Thank you, children. Next I come back and I want to teach you how can you understand the parallel rays and the divergence rays by the help of the experiment method in the laboratory. How can you understand the parallel ray and as well as the divergence ray? For understanding these concepts, you have to use in the laboratory, that is the thermocouple block. This is the thermocouple block. That is, you have to take two thermocouple block, right? So this is the one and this is the I am writing here. This is the another one thermocouple block. These two thermocouple block are similar size, right? That is just you imagine I am drawing here. It may be similar or may not, that's depend on you, but you try to understand that this is the two similar sides of the thermocouple block, right? So over this thermocouple block where you have to place on the table surface, right? You have to place on the plain table surface, not inclined table surface, plain table surface. And this thermocouple block also you have to place on the plain surface of the table, right? Then over this thermocouple block you have to fix two pins, right? This is the pin 1, this is the first pin. Next another one pin also you have to fix here, right? Then in front of the pin just you glow, what is that? A candle, right? It is a source of light, candle. You glow candle. Then the flame of the candle, it should be present. Just you imagine, it should be present above the thermocouple block, above the height. This is the height of the thermocouple block, right? This is the height I represent by the h. So this is the height of candle. This is the h2 is the height of the candle. This is the height of the thermocouple block. That means the height of the thermocouple block is equal to the height of the candle. Okay, height of the candle, that is the h2 is the height of the candle, I represent it. Then then here is the flame of the candle, right? This is called as the candle flame. And from the candle flame, the light falling on the, where it is falling on the pins, right? Over the pin, right? Light falling over the pin. Then definitely the pin is what? It is an opaque object, so the light cannot pass through the pin. Therefore, what will be happen? The shadow will be formed. If the light cannot pass through the pin, then what will be happen? Shadow will be formed. Then back of the pin, what will be happen? Shadow will be happen. That shadow, it will be parallel. The shadow, what will be formed? It will be parallel shadow, because the candle is very nearer to the pin and the intensity of the light here is the high. Here is the high. And therefore, the shadow which is formed, that shadow is the parallel shadow. This is the parallel shadow. Similarly, this experiment you done by another thermocouple, and just you keep candle somewhat far from the thermocouple block, and this is the flame of the candle, children, right? And here what will be happen? Here is the intensity of the light is very low, right? Due to the low intensity of the light falling on the pins, then what will be happen? Then the shadow become what? The shadow become divergence. The shadow is formed. What shadow form? Divergence shadow form, right? That means the diverging light is diverging, right? This is called as the divergent ray, and this is called as the parallel ray. Okay, so the parallel ray when formed, when the intensity, high intensity of the light falling on the pin, and the shadow which is formed, that is the parallel. When the intensity of the light low falling on the pin, then the shadow which is formed, this is the divergence, because the intensity of the light is low. Just I am writing here, mentioning here, low intensity of light. Low intensity, low intensity of light. Low intensity of light. This is what? This is the high intensity. High intensity of light. Right? So this is the high intensity of the light. This is the low intensity of the light. Okay, children. So I clearly inform you that when the high intensity of the light falling over the opaque object, the shadow which will be formed, this is the parallel shadow. When the low intensity of the light will be fall on the object, the shadow which is formed, this shadow is diverging, right? That is the divergence shadow will be formed. Okay, so next I am going to teach you the activity 2, right? Activity 2, which is the present in your book. In this activity 2, I want to teach you the concept, that is pole of the mirror, second is center of curvature, and the third is radius of curvature, and the fourth one is the focal point. In this concept I am going to teach you in the activity 2. Listen me carefully. Just you see here, children, I draw here concave mirror. This is the concave mirror, right? And the center, imaginary center of the concave mirror is called as the pole. I already said. And the next, the geometric center of the concave mirror, this is called as the center of curvature. I represent by C. This is the pole and this is the center of curvature, and the pole to center of curvature, this is called as the radius of curvature. Then the line which is passes through the pole and the center of curvature, this is called as the principal axis, right? And just you see here, when the light rays coming from the infinity and falling on the reflecting surface of the concave mirror. So suppose these are the rays are coming from infinity and falling on the reflecting surface of the concave mirror, then the reflected light ray direction, how you have to calculate. Very clearly I am teaching you in the activity 2. At first, what you have to decide, the angle of incident, right? This is the center of curvature and these all are the point of incident, right? So then you have to draw the normal line like this. It is a normal line. This is the angle of incident. Next, this is the point of incident. This is the center of curvature. Again, you have to draw the normal line, right? And this is the point of incident. This is the center of curvature. Again, you have to draw the normal line. Then this is the center of curvature. This is the point of incident. Again, you have to draw the normal line like this. Okay, are you clear now? And you got what? You got all these are the angle of incident. And according to the law of reflection, I already taught you. And law of reflection is angle of incident is equal to the angle of reflection. So the reflected light ray with the same angle of incident, it will be rebound back. So this is one reflected light ray. This is the angle of incident. Then the reflected light ray will be rebound back with the same angle. This is the angle of incident. Then the reflected light ray rebound back with same angle. This is the angle of incident. Again reflected light ray rebound back with same angle. Clear? So now here, just you see, these are the reflected light ray. Therefore, you have to keep the arrow mark. And remember one thing, if you did not keep the arrow mark, it did not consider as a incident ray or as the reflected ray. And what you are observing here, when all the incident light ray become parallel to the principal axis, a reflected light ray, all are converging at a point. All are converging at point. Where it is converging? Converging on the radius of curvature. Converging on the radius of curvature. Which one is the radius of curvature here? So the PC is the radius of curvature. Radius of the curvature represented by R. I can write here radius of curvature. Curvature, T-U-R-E, curvature, right? So the PC is the radius of curvature. Then all the reflected light ray when intersect at a point on the radius of curvature, this is represented by the F. What do you mean by F? F equal to focal point. This is called as the focal point. Clear? So now you see here, and the P to F. What is the P to F? P to F, this is PF, it's called as the focal length, children. Focal length, right? It is a new terminology now I used in this chapter. Before I did not explain to you. PF equal to focal length. Focal length, it is represented by the symbol small f, right? Small f. Another one is C to F also. C to F. This is also called as the focal length. This is also called as the focal length. So how I can represent it? By the help of the F. Now you see, children, the PC is what? PC is the radius of curvature. So this PC is formed by the combination of PF plus FC. Clear? PF plus FC. Just you transfer PC is the radius of curvature R. Then the PF is the focal length is small f, and FC or CF, this is also f. Clear now? Now radius of curvature R equal to f plus f. That is how much it will become. This is the 2f, right? So the radius of curvature, then equation you got here. This is the equation 1. So this is R equal to 2f. What you are got? R equal to 2f. When R equal to 2f, then the f equal to how much? This is the R by 2. So the focal length equal to, this is the another equation. This is the equation number 2. And related with this equation also you can get the problem. And suppose one mirror, radius of curvature 10 centimeter, and what is the focal length? If the question will be arise, then you can easily find out from this equation. Then f equal to R by 2. R is given 10 centimeter. Then f equal to 10 by 2. Definitely it will be 5 centimeter. So by the activity 2, I explain these all things. So today video, I hope that you see completely and you follow your book and you can easily understand, right? So thank you so much, children. Tomorrow I am going to start next topic in this chapter. Thank you so much.